4/0 MC feeder is not included in the 2005 National Electrical Code. However, the 2008 National Electrical Code does include information on 4/0 MC feeder. Within the 2008 National Electrical Code, you can find specifications for 4/0 MC feeder in Article 330, which pertains to medium voltage cable. Specifically, Table 330.46 provides details on conductor insulation thickness for 5 to 35 kV MC cable. Article 330 covers the requirements for metal-clad cable, which is designated as Type MC cable. It outlines the uses permitted and not permitted for this type of cable, as well as installation requirements to ensure safety and compliance. The scope of Article 330 includes metal-clad cable for power, control, and signal circuits. This cable is typically used in industrial and commercial applications for feeders and branch circuits. Type MC cable is a factory assembly of one or more insulated conductors, each individually insulated and enclosed in a metallic sheath of interlocking tape, smooth or corrugated metallic tube, or a spirally corrugated metallic sheath. The metallic sheath provides mechanical protection and serves as an equipment grounding conductor when installed according to the code. Regarding installation, Type MC cable must be supported and secured in accordance with Section 330.30 of the National Electrical Code. This section specifies the maximum spacing between supports and the methods for securing the cable to structures. Proper support is essential to prevent strain on the cable and its terminations. Bends in Type MC cable must be made so as not to damage the cable or reduce the internal diameter of the cable. The minimum bending radius is typically specified by the cable manufacturer and should be followed to prevent damage to the conductors or insulation. Terminations and connections for Type MC cable must be made with fittings identified for the purpose. These fittings ensure a secure and reliable connection and maintain the integrity of the cable's grounding path. When Type MC cable is installed in wet locations, the fittings must be listed for use in wet locations to prevent moisture from entering the cable. Article 330 also addresses the grounding requirements for Type MC cable. The metallic sheath of the cable is typically used as the equipment grounding conductor. To ensure effective grounding, the sheath must be properly connected to ground at both the source and the load ends of the circuit. The grounding connections must be made in accordance with Section 250 of the National Electrical Code, which provides detailed requirements for grounding and bonding. The ampacity of conductors in Type MC cable is determined by Section 310.15 of the National Electrical Code and the applicable tables in that section. The ampacity is the maximum current carrying capacity of the conductor under specific conditions. Factors such as the conductor's insulation type, ambient temperature, and the number of conductors in a raceway or cable assembly affect the ampacity. Correction factors must be applied when the ambient temperature exceeds 30 degrees Celsius or when there are more than 3 current-carrying conductors in a raceway or cable. Type MC cable is permitted for use in a variety of applications, including services, feeders, and branch circuits. It is also permitted for use in concealed or exposed installations, in dry or wet locations, and in direct burial applications when identified for such use. However, Type MC cable is not permitted for use where exposed to physical damage unless protected by conduit or other means. Additionally, it is not permitted for use in hoistways or on elevators or escalators except as permitted by other sections of the National Electrical Code. The National Electrical Code also includes requirements for marking Type MC cable. The cable must be marked with the manufacturer's name or trademark, the type of cable, the conductor size and insulation type, and the voltage rating. The marking must be durable and readily visible. In addition to the general requirements for Type MC cable, the National Electrical Code includes specific requirements for medium voltage MC cable. Medium voltage cable is defined as cable operating at voltages between 2001 and 35,000 volts. The requirements for medium voltage cable are more stringent than those for low voltage cable due to the higher voltages involved. Medium voltage MC cable must be installed in accordance with Article 330 and other applicable articles of the National Electrical Code, such as Article 310 for conductors and Article 400 for flexible cords and cables. The insulation of conductors in medium voltage MC cable must be suitable for the voltage and temperature at which the cable will operate. The insulation must also be resistant to moisture, chemicals, and other environmental factors. The metallic sheath of medium voltage MC cable must be effectively grounded to provide a low impedance path for fault currents. The grounding system must be designed to minimize the risk of electric shock and to prevent damage to equipment. Terminations and splices for medium voltage MC cable must be made with fittings and methods identified for the purpose. These fittings and methods must be designed to withstand the high voltages and stresses associated with medium voltage systems. Medium voltage MC cable is typically used in industrial and commercial applications for feeders and branch circuits supplying large loads such as motors, transformers, and switchgear. It is also used in underground distribution systems for supplying power to buildings and other facilities. The National Electrical Code is updated every 3 years to reflect changes in technology, industry practices, and safety standards. It is essential for electrical professionals to stay up to date with the latest edition of the National Electrical Code to ensure that their installations comply with the current requirements. In summary, to find information on 4/0 MC feeder within the National Electrical Code, you should consult the 2008 edition or later. Article 330 provides comprehensive guidelines, and Table 330.46 specifically addresses conductor insulation thickness for medium voltage applications, which is relevant to 4/0 MC feeder installations. Always refer to the latest edition of the National Electrical Code for the most accurate and up-to-date information. It's also important to note that local codes and regulations may have additional requirements or amendments to the National Electrical Code. Therefore, it is always advisable to consult with local authorities and qualified electrical inspectors to ensure compliance with all applicable codes and regulations. When working with electrical systems, safety should always be the top priority. It is essential to follow safe work practices, use appropriate personal protective equipment, and energize circuits before working on them. Only qualified and licensed electricians should perform electrical work. In addition to the National Electrical Code, other standards and resources can provide valuable information on electrical installations. These include standards from organizations such as the Institute of Electrical and Electronics Engineers, the National Fire Protection Association, and the American National Standards Institute. Manufacturers' instructions and product listings also provide important information on the proper installation and use of electrical equipment. Continuous learning and professional development are essential for electrical professionals to stay informed about the latest technologies, codes, and best practices. Participating in training courses, attending industry conferences, and reading technical publications can help electricians and other electrical professionals enhance their knowledge and skills. Remember that the National Electrical Code is a complex and comprehensive document. It is not intended to be a substitute for proper education, training, and experience. Electrical professionals should always exercise sound engineering judgment and consult with qualified experts when necessary. By following the National Electrical Code, adhering to safe work practices, and staying informed about the latest developments in the electrical industry, you can help ensure the safety and reliability of electrical systems. The 4/0 MC feeder size is commonly used for larger loads requiring higher amperage. The 4/0 refers to the American wire gauge, or AUG, which is a standardized system for denoting wire sizes. In this system, larger numbers indicate smaller wires, and conversely smaller numbers and numbers with slashes, like 4/0, indicate larger wires. A 4/0 AWG wire has a significantly larger cross-sectional area than, say, a 12 AWG or 14 AWG wire, which are commonly used in residential wiring for lighting and receptacle circuits. This larger cross-sectional area allows the 4/0 wire to carry a much higher current without overheating, which is critical for safety and efficiency. When selecting a 4/0 MC feeder, several factors must be considered. Firstly, the ampacity of the wire must be sufficient to handle the anticipated load. Ampacity is the maximum amount of electrical current a conductor can carry continuously without exceeding its temperature rating. The National Electrical Code provides tables that list the ampacities of different wire sizes and insulation types, taking into account factors such as ambient temperature and the number of current-carrying conductors in a raceway or cable. It is crucial to consult these tables and apply any necessary correction factors to ensure that the selected wire size is adequate for the intended application. Secondly, the voltage drop in the feeder must be within acceptable limits. Voltage drop is the decrease in voltage that occurs along a conductor due to its resistance. Excessive voltage drop can cause equipment to malfunction or operate inefficiently. The National Electrical Code recommends limiting the voltage drop in feeders to 3% and the total voltage drop in feeders and branch circuits combined to 5%. To calculate voltage drop, you need to know the length of the feeder, the current it will carry, and the resistance of the wire. There are online calculators and software tools that can assist with these calculations. If the calculated voltage drop exceeds the acceptable limits, you may need to increase the wire size to reduce the resistance and lower the voltage drop. Thirdly, the insulation type of the wire must be suitable for the environment in which it will be installed. Different insulation types have different temperature ratings and resistance to moisture, chemicals, and other environmental factors. For example, THHN insulation is commonly used for dry locations, while THWN insulation is suitable for wet locations. The National Electrical Code specifies the types of insulation that are permitted for different applications. It is essential to select an insulation type that is compatible with the intended environment to ensure the long-term reliability and safety of the electrical system. Finally, the method of installation must comply with the requirements of the National Electrical Code. Type MC cable can be installed in a variety of ways, including exposed, concealed, and direct burial. However, there are specific requirements for each method of installation. For example, Type MC cable that is installed in exposed locations must be supported and secured at intervals specified in the code. Type MC cable that is direct buried must be identified for direct burial use and installed at the proper depth. It is crucial to follow these requirements to ensure that the cable is properly protected and that the electrical system is safe and reliable. In addition to these factors, it is also important to consider the cost of the wire and the availability of qualified electricians to install it. Larger wire sizes, such as 4/0, are more expensive than smaller wire sizes. It may also be more difficult to find qualified electricians who are experienced in working with larger wire sizes. It is important to weigh these factors carefully when selecting a 4/0 MC feeder to ensure that the selected option is both cost-effective and practical. The 2008 NEC inclusion of 4/0 MC feeder specifications indicates its recognition of the growing use and importance of this cable type in various electrical applications. This inclusion provides standardized guidelines for its safe and effective installation, contributing to the overall safety and reliability of electrical systems. Remember to consult the specific tables and sections within Article 330 of the 2008 NEC for detailed requirements related to 4/0 MC feeder installations. These requirements cover aspects such as conductor ampacity, overcurrent protection, grounding, and bonding, ensuring that the installation meets the necessary safety standards. Moreover, always check for any local amendments or regulations that may supplement or modify the NEC requirements. Local jurisdictions may have specific rules or interpretations that must be followed. Consulting with local electrical inspectors or authorities is essential to ensure compliance with all applicable codes and regulations. When working with electrical systems, it is paramount to prioritize safety. Always de-energize circuits before working on them, use appropriate personal protective equipment, and follow safe work practices. If you are not a qualified electrician, it is crucial to hire a licensed professional to perform any electrical work. This ensures that the work is done safely and correctly, minimizing the risk of electrical hazards. The information provided in the NEC and other electrical codes is intended to provide guidance and ensure safety. However, it is not a substitute for proper training, experience, and judgment. Electrical professionals should always exercise sound engineering judgment and consult with qualified experts when necessary. By adhering to these principles, you can contribute to the safe and reliable operation of electrical systems, protecting people and property from electrical hazards. And while the 2005 NEC may not explicitly mention 4/0 MC feeder, the general principles and requirements for electrical installations still apply. These principles cover aspects such as conductor sizing, overcurrent protection, grounding, and bonding. Even in the absence of specific guidance for 4/0 MC feeder, it is essential to apply these general principles to ensure a safe and code-compliant installation. In such cases, it may be necessary to consult with qualified electrical engineers or inspectors to determine the appropriate requirements. They can provide expert guidance based on their knowledge of the NEC and other relevant standards. They can also help ensure that the installation meets the intent of the code, even in the absence of specific provisions. The NEC is a dynamic document that is constantly evolving to reflect changes in technology and industry practices. The inclusion of 4/0 MC feeder in the 2008 NEC is a testament to this evolution. As new technologies and applications emerge, the NEC is updated to provide guidance and ensure safety. This continuous improvement process helps to keep the electrical industry at the forefront of safety and innovation. Staying up to date with the latest edition of the NEC is crucial for all electrical professionals. This allows them to stay informed about the latest requirements and best practices. It also helps them to ensure that their installations are safe, code-compliant, and reliable. There are many resources available to help electrical professionals stay up to date with the NEC. These include training courses, seminars, workshops, and publications. Participating in these activities can help electrical professionals enhance their knowledge and skills and stay abreast of the latest developments in the industry. In addition to the NEC, other standards and resources can provide valuable information on electrical installations. These include standards from organizations such as the Institute of Electrical and Electronics Engineers, the National Fire Protection Association, and the American National Standards Institute. Manufacturers' instructions and product listings also provide important information on the proper installation and use of electrical equipment. Consulting these resources can help electrical professionals make informed decisions and ensure that their installations meet the highest standards of safety and quality. It is also important to remember that the NEC is not a substitute for proper education, training, and experience. Electrical professionals should always exercise sound engineering judgment and consult with qualified experts when necessary. By combining their knowledge and skills with the guidance provided in the NEC and other resources, they can ensure the safety and reliability of electrical systems. The information regarding 4/0 MC feeder and the NEC is intended to provide general guidance and is not a substitute for professional advice. Always consult with qualified electrical professionals for specific applications and installations. They can assess the specific requirements of the project and provide tailored recommendations that meet all applicable codes and regulations. Remember, safety is always a top priority when working with electrical systems.